Assalamu alaikum, sir.
Walaikum assalam. We are doing questions on kinematics today, and this is a paper 2 session, and I'm writing the question number, year number. If you have a past paper book, any topical unsolved past paper book, you can take it out, and it will be ideal if you get the question. I have written the year number. So if you get the question and you solve it on the sheet, it will be best.
Okay, sir.
This is November 2013, 23-3. I'm starting the question and define the term velocity. Velocity is the rate of change of
Displacement.
yes, velocity is the rate of change of displacement. What is acceleration? A famous definition appeared many times. It's a good memory always. Rate of change of velocity.
Okay, sir.
Now you move forward and read the next part. A car of mass 1500 kg travels along a straight horizontal road. The variation with time of the displacement x of the car is shown. Y-axis is distance and x-axis is time. It's a distance time graph. It's a displacement time graph. And he says, use figure 3.1 to describe qualitatively the velocity of the car describe qualitatively the velocity of the car during the first 6 seconds of the motion shown. This is one of their favorite topic, and whenever I explain sketches, I always tell students that look, a sketch has few parameters. Sketch has few parameters: gradient, area, ratio, and then the shape. So the the gradient of a displacement time sketch shows velocity. So first I recall that gradient is equal to velocity. First 6 seconds. Look at this screen. You can put a ruler also, because the line is straight, then bends, and again it is straight. It's a 6-second motion. Examiner says qualitatively. Qualitatively means that you're not supposed to give any numbers. You're not supposed to find any numerical wording. I repeat my concept. A graph, a sketch. A sketch is always interpreted by gradient, by area, by shape. Now, look at the graph. Can anyone tell me till when the line is straight?
From 0 to 2 seconds and from 4 to 6 seconds.
So for 0 to 2, the line is straight. So I will say that velocity is constant, acceleration is 0. How I can say velocity is constant? Because the point is there, because slightly bending before 2, but initially the line is straight. I don't have to give numbers. Initially velocity is constant and acceleration is 0. Then the graph is bending towards x-axis, which means gradient is decreasing. So velocity is decreasing. It's a retardation case. In the last, velocity, the line is straight again. In the last, the line is straight again. Velocity is constant and acceleration is 0. I mark the graph, and now I come here and I look at the question. This is a 3-mark question. The figures used to describe qualitatively the velocity of the car during the first 6 seconds. He says, give reasons for your answer. I have already developed the graph sense. I have already developed the sense of the graph. And now I have to convince examiner by referring to gradient. So now you have to read the question again, and you have to tell me that three-mark question. So can anyone help me to start it? I can say the graph is in front of you. Now you will say initially the velocity is constant. I will not mention acceleration, as examiner want only velocity. Initially velocity is constant. I will not mention numbers because examiner wants qualitatively. Then velocity decreases, and in the last, velocity becomes constant again. Okay, now can anyone tell me that the first patch and the last patch, do they have the same gradient? I circle here, look at this part and look at this part. Both lines are straight, but are they having the same gradient? If I say this is patch 1, I say this is patch 2. Patch 1 and patch 2, are they having the same gradient, or patch 2 has less gradient?
Batch 2 has less gradients, sir.
So please reply. So no one replied. So the first part has a steeper segment and 2 has a less steeper segment. So we will tell the examiner, that velocity is constant in the start, then velocity decreases, then velocity becomes constant again. But obviously, velocity has decreased. So the last gradient is less than the first one. So the last part, the object is moving at a lower velocity than the first batch. So these are the 3 marks to cover. Okay. So you will comment on the statement here. What you will write here? Initially, V is constant, then V decreases, then V becomes constant at a lower value. This is the answer for our part number 1. Calculate the average velocity during the time interval 0 till 1.5. He wants average velocity 0 till 1.5. I made a line here and it's reading somewhere here. Not very precise, but it's somewhere between the 2 lines. It's coming about here.
Sir, can you take the meet distance displacement value for 45?
It's approximately 45. Actually, my line is going a bit high and somehow it's not coming down, but it is 45 in between. So if you people can also look at the sketch and you people can help me to read this position.
Sir, the distance is 45, yeah?
Look at this position. Okay, now the 0 position is marked and 1.5 position is marked. He's asking for average velocity 0 till 1.5. So do the calculation and let me know the answer. But everyone should take part in the calculation.
Sir, is the answer 30?
Somehow I'm unable to hear anyone. Maybe some error is there because even Saad, if you are speaking something, I can't hear. Can anyone else, Zen, can you hear me? Because
Yes,
I'm
sir.
not able to hear
Can you
Saad
hear
and
me, sir?
I might be having any error.
Sir, can you hear me?
I'm not able to hear Zen also. Okay, maybe that is an error in the system.
Sir, how about now? Can you hear me now? Hello, sir.
Well, technology. Zen, I can hear you now somehow because I
Oh,
think
great.
because of your magical mic, I can hear you back.
ठीक है,
Saad,
great.
can you try again because Zen has a magic of opening mics now? Can you
So
say
you're
something,
asking,
Saad?
so you can hear me?
No, I can't hear Saad still.
Sir, I can hear साथ. I think आपके end पे कोई मसला होगा, अभी आपकी आवाज भी कट रही थी.
But well, I'm sure. But I can hear you loud and clear. But somehow I cannot hear Saad. And anyways, let's proceed. Saad, I can't hear you, unfortunately. And this is a problem. Then any.
So he can convey whatever he wants to say through me. मैं बता दूंगा मुझे आवाज आ रही है.
Otherwise, he can write on the chat also.
Yes,
This
yes.
possibility. Let's see. But anyways, we have to do this calculation. We have to do this calculation. Fine, it's okay. So let's see with the other people can also write their answer. Who, if anyone doesn't want to speak on the chat also. I want to have a calculation result here, and you people can share with me the answer. 1.5, the velocity is 4.5. So he wants me to give the final velocity. The time is 1.5. First numbers are 0, so I'm not reading it. It's 45 upon 1.5. I'm taking 45 as the distance from the screen. And I'm using the old formula of our O-level. Average velocity is equal to displacement upon time. So 33 point. Achha. How come it's becoming so big? 30. Well, the numbers are 33 meter. I have 45. I have simply 45 upon 1.5. So if I round it, it will be 30. 30 looks fine to me. Then what are you getting?
So I'm just fill this in the calculator one last time.
So that the average acceleration between t.
Yes, sir, 30 aa raha hai.
Okay, then you have to keep your mic off in between so we can see what is the possible reason. Show that the average acceleration between t is equal to 1.5 and t is equal to 4 is minus 7.2. So let's try part number 3. Yes, 30, 30, 30 is right. So we got 30 as the answer. Show that the average acceleration between 1.5 and 4 seconds is 7.2. The formula for acceleration is v minus u upon delta t, the change in time. So at t is equal to 4, and t is equal to 1.5, I think I should find the velocity as I have the velocity at 1.5. I should try to find the velocity at 4, and then I can find the acceleration. So let's try to work out the acceleration. Sad, I think you can try to disconnect and connect again. I think this is the reason coming up that there is an issue. Yes, Yogita, right answer, and good majority people gave me the right answers for the last part. I'm reading now at 4. I'm reading at 4. Now, can anyone tell me that what is this number right below 100? $98. Good suggestion. 98. Majority people gave me 98. So I think 98 is looking fine to me. And I should first find the velocity at 4. So velocity at t is equal to 4. Now, as this is we have to be very careful that how should I find the velocity? I got this number 98. .5, but okay, at 4 is 24.5. Some people are giving this 24.5. Actually, I have got this value 98 as my displacement. And this is a patch. The problem which every good student should understand, the trap is there that you divide 98 by 4. That would be wrong. Actually, gradient based calculation can be done when the line is straight. Remember, gradient based calculation can be done when the line is straight. 98 is the displacement, which means it is at a mark of 98 when 4. You can look at the screen, velocity is decreasing. I can't read below 98. So I have to go forward and see if I read from the maximum part, it is 6. If I can read from the 6, now why I am reading from 6? Because it's a straight line. Look, I am reading from here. What is this number? Right above 120, right above 120, this number will be 122. Why I am doing that? Because it's a straight line in between. Now 122 minus 98 upon 6 minus 4. Now look at this working. So help me to find the velocity.
Sir, is it 12?
Oh, Saad, your voice is back. Good. And it is 12 meter per second. I got the velocity at 4 and I have already the velocity at 3. Now I can use the formula. Velocity at 1.5, sorry. I have the velocity at 1.5, that is 30. Now I have the calculation. So, and 1.5 to 1.5 to 4. So now I can use the formula. A is equal to V minus U upon delta T. So if you put the data now, it's 30 minus 12. 30 minus 12. And the time is 1.4, 1.5 minus 4. So solve this calculation.
Sir, it's minus 7.2.
So this is the step. And again, it should be understood that examiners always prefer to trap the people, as a trap was there, that normally people won't look at the velocity changing before 4, and they will use the velocity at 4. Calculate the average force acting on the car between 1.5 and 4. So now we put the formula, average force F is equal to m8. I have the acceleration, which is minus 7.2. And if I have the mass, yes, the mass is 1500 kg. If you do not put negative here, it is fine, because it's asking for average force. But if you keep negative, it's also fine. Now get the answer, please, and let me know.
108,000
Yes,
Newton.
100, 800, 10800. Then a famous discussion is there. How to control the number of significant figures. In the question, everywhere examiner has used 2 sig fig. Look, all data, examiner data is 2 sig fig. So I can use 1, 1, and then I will put 1, 2, 3 zeros.
Sir, it's 108,000 Newton, not 10,800 Newton, sir.
Oh, is it 108 triple zero?
Yeah.
Achha. Can you check again, because 10, because some people are giving me 10800. Then what are you getting? Because is it 108 triple zero or 10800?
Sorry, sir, it's 0000.
Then it's fine. Then we are done with this question.
Yes, sir, 00.
Then very late response, but still it's okay. And June 14, 21, 1. Please refer to this year number, and if somehow you are able to get the question from the past paper book, if you have a past paper book, it would be very good because you will solve in the book. Define velocity. Velocity is the rate of change. Velocity is the rate of change of displacement. Distinguish between speed and velocity. And everyone knows from O level that speed is a scalar and velocity is a vector. So I take up this question myself, the easy one. And now I am here on the graph. A car of mass 1500 kg. A car of mass 1500 kg moves along a straight horizontal road. The variation with time of the velocity for the car is shown. He has shown us a graph. This time it's a velocity time graph. The brakes of the car are applied from 1 to 3.5 seconds for the time when the brakes are applied. Calculate the distance moved by the car. Remember the rule that distance is the area under a sketch. Distance traveled is the area under the sketch. So if I mark the position, this one, and then I mark the position, the breaking point where the speed is decreasing. I know that if distance, I know that if the brakes are working, the distance would be, the speed would be decreasing. So one number is 1, and the second number looks to me is 3.5. Distance moved by the car, and if I see this distance looks to me like a trapezium.
Yes, sir.
So either you use the formula of a trapezium, or you can make a rectangle here and a triangle and add them. Whatever is convenient is fine. So I refer it as an area of a trapezium. Area of a trapezium is half into height into sum of parallel sides. This is the formula. Please copy the formula and then help me to work out.
Sir, is the distance 94.5 meters?
Okay, let's see what others have to say there. I think the height is 2.5. If I mark here, it is 2.5. One parallel side is looking to be 32, and the other is looking to me as 18. So I have a 32 and I have a 18. So half into 2.5 into 18 plus 32. 62.5. One suggestion, 62.5. Any other answer? One answer is 62.5.
So the area of the trapezium is 62.5, but like the area of the entire distance is 94.5.
No, only the brakes are applied.
Oh, okay, sir. So it's 62.5 then.
Because we're not supposed to find the total area. We have to stay with the area when the vehicle is slowing down. The braking distance in our dynamics language, O-level physics, we used to call it braking distance. Now, calculate the magnitude of the resultant force on the car. Resultant force is mass into acceleration. So we need acceleration. So either we go for gradient, and then we use F is equal to ma. We have the mass, but we do not need, but we do not have the acceleration. So acceleration this is the formula. Look at this is again for the time when the brakes are applied. For the time when the brakes are applied, look at the gradient. One is 1,32. If I read the coordinates, 1,32. And the second is 3.5, 18. Three point five comma 18. So if I put the points here, I can get the acceleration. Now, please help me to get the acceleration first. Acceleration, please find acceleration for me.
Okay, sir.
All people should contribute. -5. Okay. -5 or -5.6? -5.6. Acha. Okay.
Minus 5.6, sir.
Good. And then in the paper, it would be good if you use the space intelligently and make a space line, because normally space is limited for good presentation if you do not partition the space. So answer of the force is now needed.
So is it minus
Minus you can include, and let's see what answer is coming after multiplication. Minus can be kept here. So 8,400, 2-3 people are writing 8,400.
so is it 8,400 Newton?
Yes. the direction of the motion of the car in B at t is equal to 2 is shown in the figure. Shows with arrows the direction of the acceleration, label arrow. So he's asking for time is equal to 2. This is time is equal to 2 when the car is braking. As the car is applying the brakes, and the answer, my answer is also coming negative. So should I show force and acceleration are always in the same direction? So what about the force? Force is forward or backward?
Forward, sir.
When the car is applying the brakes, when
Yeah.
the car is applying the brakes, what
Sir,
about,
then the force is backward.
yes, the force is backward. When the car is applying the brakes, the arrows should be backward. So I will show two arrows and the both arrows should be backward. The arrows are backward because the car is applying the brakes.
Yes, sir.
Explain what is meant by a scalar quantity and by a vector quantity. This is June 14. Scalar is a quantity which is defined completely without direction. Vector is a quantity which needs direction. Then look at this screen. It's a projectile. A ball leaves point P at the top of a cliff with a horizontal velocity of 15, projectile motion. And this is called a category of, half projectile. Height of
Yes.
the cliff, air resistance is negligible. Calculate the vertical velocity of the ball just before it makes impact with the ground. So let's make an impact of the ball with the ground. I have made the impact. And now I'm planning to show the components which examiner want me to see. Now this is one component. Vertical component of velocity is 0 at the start. It's a downward motion, so acceleration will be equal to, for the downward motion, acceleration will be equal to plus
9.8.
u is equal to 0. And S is 25 meter. Now the data is there.
Yeah.
So I made the data and you people are now supposed to help me. I need V.
Sir, you make V the subject of the formula.
You can make V the subject, or you can move it there.
There's the answer 22.1.
22.1. Okay, let's see what other people are getting. $22.1. Two people are saying 22.1. So I think 22.1 should be the right answer. Two people are saying. Okay, any other want to contribute the answer? Show that the time taken for the ball to fall to the ground is 2.3. For time, you can take any component. It's allowed because time is the same for both component.
So the formula that we should use is half U T plus
That formula also, it's a downward motion. So I'm first making the data as my habit, and then I can see, because I don't want to get a quadratic equation anytime because that will waste my time. This is the full data. Actually, data is quite comprehensive. So it means actually we have everything.
So the answer in 2 decimals would be 2.25.
2.3, 2.25. So if you round it to two significant figure,
It's going to be 2.3.
2.26 or 2.23 is fine. For two significant figure is 2.3. Calculate the magnitude of the displacement of the ball at point Q from P. Q from P. Achha, he wants a straight line. Displacement is a vector form. It is always in a straight line. So let me draw a straight line here. Okay, this is the displacement. This is the displacement. Now, what should I do to find the displacement? Either I go for I have the vertical displacement, and if I find the horizontal displacement, I can make a triangle and find the, so if I make a line here, then I can make a triangle. I'm getting a triangle here. And
Sir,
yes.
How do you like the way that we find the horizontal displacement is by multiplying the horizontal velocity with the total time, yeah?
I'm thinking to find the horizontal displacement dx.
Yeah.
My plan is to find horizontal displacement because I have a permanent horizontal component 15 with me.
Yeah.
15 horizontal velocity. So I have a formula: displacement x is equal to Vx into t. Horizontal displacement is equal to horizontal component into 22.6. And now please do this calculation part.
Sir, the time is not 22.6. It's 2.26, sir, the time.
Sorry. I have written 22.6. Okay, it's 2.26. So please make this correction and quickly help me to find the displacement.
33.9, sir.
33.9, but I have another answer. One student is saying 34.5. Now we need quick response whether we can fix
Sir,
it.
34.5. 34.5 is what you get when you multiply it with the 2.3.
I'm asking first that. Okay, fine. I got it. Now, can you tell me what's the answer for multiplication step?
33 point.
So now do this working.
Sir,
33.
42.6.
And what we are getting, for D, the Pythagoras theorem,
42.6.
42.6. Now we move to the last part. Explain why the distance traveled by the ball is different from. It's a question like area case. Why the distance traveled by the ball is different from the magnitude of the displacement of the ball. So distance is a scalar and displacement is a vector. Being a vector, displacement is being taken on a straight line. This can be seen from here. This can be seen from here. Displacement is in a straight line and distance can be on a curve. So you will tell examiner that, look, displacement is a vector and distance is a scalar. So they can't be the same. Displacement is actually occurring on a straight line. This is year number June 14232. So always whenever you come across a theory question, it is very recommended that if you get a chance and you should look for you should try to look for the examiner report. Examiner reports are very good when you are discussing the theory. So I'm trying to use it, and we have plus just 2 minutes, 2 to 3 minutes. Question number 2 and last part. So I have opened the examiner report just to make a habit that this is something which is helpful. And look at this part. Many answers did not relate to the question and merely gave vague statement of distance and displacement. Description of the distance as the length traveled along the actual path of the ball, the curved path, and displacement as the straight line path were made by only a minority of the candidates. So this is where examiner reports are very amazing, and they are really the way for A grade. So now look at this bracket. Examiners want students to relate to the question. The distance is the length traveled along the actual path of the ball, the curved path, and displacement is the straight line path which was taken by the ball. So look at this bracket before we finish our class today. So look at this bracket and you can refer to the bracket part and you can answer the question in that way. Examiners are always impressed when student relates the question in their answer. When students relate the question in their answer. So
Sir,
that is, yes, go ahead,
can
sir.
can you show the question again?
So
Okay, sir.
we are stopping here. It will be our last point to remember that for theory questions, it is always recommended to use the examiner reports. We are stopping here and we will inshallah continue in our next class. Allah
Okay.
Hafiz.
Allah Hafiz, sir.